This video continues on from lesson 8.3, but now we're focusing on part 2, which is the properties of logarithms. And I almost said it when I was reading that. I almost said properties of exponents. We know that. Properties of exponents says that if I am multiplying, so I'll have a squared times a cubed. If I'm multiplying the same base, I add the exponents. If I'm dividing the same base, so a to the 9th over a cubed, I subtract my exponents. And there's also a power rule which says if I have a squared and I'm raising that to the 4th power, I multiply, I bring that power to the power. So I almost said properties of exponents, and it's not a bad thing, because really what we learned from the previous lesson was that logarithms are equal to powers. I mean, that was the main idea behind converting, was that a logarithmic expression is equal to an exponent. It's equal to a power. So why can't I think of it like my properties of exponents then? I mean, properties of powers. So let's see if that helps. All right, so there's an addition rule for logarithms, but really it's a product rule. If I am adding two logs together, you have to remember that a log is really a power. So I have a power here, we'll call it power 1, and I have a power here, we'll call it power 2. So really what that left side of the equal sign is saying is I am adding two powers together. So let me take a look. When do we add two powers together? Well, we added two powers together with our product rule. And so notice, what do you end up doing to the two values, your m and your n? I take these two and I can merge them into a single logarithmic expression by multiplying them. So it's kind of like the backwards thinking of what we do with properties of exponents. If I'm adding logs, that means I'm adding powers. You add powers when you multiply. So we can take an expression that involves an addition sign, subtraction sign, and we can merge them into one log. So one example, and we'll do it with numbers, is if I have log, and I'll make up any base, so log base 3 of 7 plus log base 3 of 2. If I want to take these and merge them into a single logarithm, just one log rather than a log plus a log, I'm going to take, so I have log base 3, I'm going to take my two numbers, my two values, and I'm going to multiply them together. That is the addition rule. It is just like the product rule for properties of exponents on it. If you are subtracting logs, you can merge those together as well. And it's really the same idea. Is I'm not dealing with a log. A logarithmic expression is equal to a power. I have a power here, we'll call it power 1 minus, and I have a power here, we'll call it power 2. Well, when do I subtract exponents? When do I subtract powers? Well, I subtract powers when I'm dividing, finding the quotient. So that's my quotient rule. So notice I merge my two values together into a single logarithm by dividing them on it. So it's the backwards idea of properties of exponents. If I am subtracting logs, that means I am subtracting exponents, which means I performed the operation of division. If I am adding logs, that means I'm adding exponents, which means I performed the operation of multiplication. So let's look at an example of it. If I have log, again, just making them numbers, if I have log base 5 of 24 minus log base 5 of 3, I want to merge those into one single logarithm, log base 5 of something. I'm subtracting logs, which means I'm subtracting powers. So I'm going to take my two numbers, the 24 and the 3, and I'm going to divide them together, and I'm going to get 8. It's that easy. We are dealing with the quotient rule for this. Now, what if it wasn't nice numbers? I mean, 24 and 3, that was really nice because I could do that division. But what if I couldn't do the division? What if it was 24 log base 5 of 24 minus log base 5 is 7? How do you merge those together? Well, you divide them, 24 over 7, and just leave it alone. So that's your quotient rule for exponents on it. So when you're subtracting logs, you merge them together in a single log by doing division. Now, this one's a little weird. It's the power rule of exponents. If you have a coefficient, and I'm going to break it down this way, P for power, of course. If I have a power, I'm multiplying it to another power. So this first one right here, we can call that power 1. I am multiplying that by this logarithm expression, which is power 2. When do you multiply a power to another power? And that's right here, when you're dealing with a power rule. And so what happens, and this one becomes more visual on it, is you take the coefficient and you bring it up to become a power. And that's what we did here, is that P got brought up and became the exponent there. So that's your power rule on it. And it becomes more visual. So if I have 3 log base 2 of 5. If I want to apply my power rule, I'm going to take this coefficient and I'm going to bring it up to become a power. And so I have log base 2 of 5 cubed. And I could change that to 125 if I want. And by the way, it doesn't even have to be a number on it. I could say an x here. And then this would be x cubed for it. So those are your properties of logarithms. They're used to merge expressions together because that's the only way we can solve, which is what part 3 deals with on this lesson. So this part 2, we're just going to practice this merging. We're going to practice getting them together because you can't have a plus sign, you can't have a minus sign, you can't have a coefficient. Not allowed. When you are solving logarithmic equations, it has to be one single log. It cannot have a plus sign, it cannot have a minus sign, which is why we learn these. It allows us to write it as one single log. So product rule says when you are adding logs, merge them into a single logarithmic expression by multiplying. That's what we're going to do. So when I look at this first one, log base 3 of x plus 5 plus log base 3 of 3x minus 7 equals log base 3 of 18. Right away, I see a plus sign. That tells me I have to merge my two expressions together by using the product rule. So I am going to take x plus 5, and I'm going to take 3x minus 7. I can take that entire left side. So let me leave the right side alone. Bam, bam, log base 3 of 18. I'm going to leave that entire right side alone. I'm going to take those two expressions, and I can merge them into one single logarithm by multiplying them together. X plus 5 times 3x minus 7. That is your product rule. You are going to take your two logarithmic expressions and you are going to find the product of them for it. There's a product rule. Merge them together, and then in the future, part 3, we are going to learn how to solve that. Right now, we're just practicing the merging. Quotient rule says when you are subtracting logs, you can merge them into a single logarithmic expression by dividing. So when I see log base 5 of 7x minus 8 minus log base 5 of 3x plus 5 equals log base 5 of 2, I see right away there's a minus sign. Too many expressions on the left-hand side. I like the right-hand side. The right-hand side only has one expression. It's so simple. It's easy. Log base 5 of 2. Good. The left side, more complicated, but that minus sign helps me. on it. I can take my two log base 5 and merge them together by dividing them. So I can put 7x minus 8 over 3x plus 5. And that is how you merge them together. Now, we will focus on the solving in part 3. Right now, we're focusing on learning how to read the problems. So, power rule says when multiplying to a log, which means you have a coefficient. When I have a coefficient of a logarithm, it becomes the power, or you can think of it as the exponent of the expression. And so what this means, I cannot have a coefficient in front of a log. Equations have to say, logarithms, log base number equals power. I mean, that's what we've been focusing on in this series of videos. Log of a base number equals power. What power of blank gives me blank? It has to look like that, which means, notice there is no coefficient here. I can't have one. So that 2 is a problem. So when I see that 2, what comes to my mind is I need to find a way to get rid of it. I am taking and I am multiplying to a power. When I multiply to a power, then I can really take this 2 and I can make it power of my x. So I have log base 8, now x squared. That exponent came up, boom, and you have log base 8 of x squared equals 16. Now that looks good. There's no coefficient, there's no plus sign, there's no minus sign. I can solve in a future lesson. So that's really what we're focusing on in part 2 is how do I merge? How do I merge? Because these structures are where we're going in part 3. Right now, we're going to practice just going through with it. Now, another property is equality. And again, we're trying to build into part 3 for it. Instead of jumping in, just starting to do it, we're trying to make sure we understand how to read the problems first. Now, when you are solving, there's 2 structures for solving. You're going to have a log equal a value. So really, I'm going to write down here, you're going to have logs on one side. Or you can have a log equal to a log, which means you have logs on both sides. That structure determines how you're going to solve. If you have a log equal to a value, you're going to convert to exponential form. And I want to scroll up and show you. That's what we did right here. You've already had a log equal value. You've had logs equal to powers. So in this case, let's try one out. I don't like it. It's got a plus sign. That stands out to me. Log base 4 of x plus log base 4 of 6 equals 3. Can't solve it. I don't have the equality property yet. I need to merge together into a single log. That's what I have to do. I mean, the right side looks good. Equals 3. That's beautiful. That's simple. So I have to merge these together. So I go through and I look at it. Well, what am I doing? I am adding my logs, which means I am adding powers. So I'm going to do my product. I'm going to take that x and I'm going to take that 6 and I'm going to multiply them together and I'm going to get 6x. That is really the same thing we did above. We're practicing that rule again. But to solve this, and we're just going to look at how we would solve it. What I would do is I would see I have a log on one side of the equation. So I have to convert to exponential form. If only we learned how to convert to exponential form before, and we have right up there. Let me grab that. So right up here, we have it. We've learned how to do that all on the previous side. We read it like a question. When I see the word log, I think of it as what power of 4, 4 is my base, so what power of 4, don't know this power yet, gives me my number, that's my number, 6x. What power of 4 gives me 6x? Well, it tells me the power is 3. So there we go, the power is 3. So 4 cubed equals 6x. I can solve that. So when you have a log on one side, convert to exponential form. Merge them together and convert to exponential form. You always have to figure out, do you have log equal value or do you have log equals log? Now this one, and I don't know if you want to star it, you want to mark it. This is the one most students miss. It's interesting because they'll get the front side right. They'll do all this stuff in part one right. But for some reason, when you start throwing these equal signs in there with the merging with the properties, it slips their mind. So that's the harder one. Now, when it's like this, if you have a log on both sides, again, unfortunately, I made it a plus sign again, so it is a product rule. I should have made a minus sign, have a little bit of fun, do something different. We merge product rule together. When we're adding, I'm going to multiply these together. So I'm going to take 3 times x minus 4, and that's going to allow me to merge it and say it equals log base 21. I mean, look how nice that right side is. It's one log all by itself. It's beautiful. So I had to do that to the left side. So it's simple. So you go through, like, if it's log equals log, guess what? You can cross out the logs because they're the exact same. What power of 5 on the left side and on the right side? What power of 5? They are the same base. So I can just say, and I'm going to distribute, I can say 3x minus 12 equals 21, and I have the ability to solve that. So we learn the properties of merging to get it so we can set up for solving. So in these problems, what we're trying to figure out to do is not solving them. We're going to set up for solving. So when we read these problems, we're just going to practice. We're going to answer these two questions. I'm going to merge. How? Am I going to do product rule, quotient rule, power rule? I'm going to convert to exponential form, or am I going to cross out the logs? I want to know which of these in that box am I doing. Part of logarithms is learning to read the equation first. So first off, how am I going to merge? Log base 9 of 2x minus 3 plus log base 9 of x equals log base 9 of 5. I see plus sign. That's product rule. I hate that left side. It has too many logs. I like this right side. It is one log all by itself, log base 9 of 5. So I am going to merge these two logs on the left side together into one single log, log base 9, by multiplying the 2x minus 3 and the x together. And I'm going to write it x times 2x minus 3. So I merged, let's write this down, I merged by multiplication. That is how I merged. Perfect. Now I answer the first part. How am I going to merge them together? I'm going to merge them by multiplying because it's a plus sign. Done. The next question is, how am I going to solve? Am I going to take right here, look at what I have. Log base 9 of x times 2x minus 3 equals log base 9 of 5. Am I dealing with scenario 1, where I have one log equal a value, or am I dealing with scenario 2, which says I have a log equal to a log? And in this case, I have a log on both sides. So what I'm going to do is I'm going to cross out the logs. I'm only going to be left with, and I'm going to distribute this, 2x squared minus 3x equals 5. I can cross, let's put it in red, I can cross out my logs. So determine whether you will merge and convert to the exponential form or merge and cross out. Well, I've answered the question. I'm going to merge multiplication and I'm going to cross out my logs. We're not solving right now. We are only setting them up for solving to get them practicing. So if we look at this one, how am I going to merge this one together? Log base 6 of 5x minus 4 minus log base 6 of 7 equals 3. So if I look at this one, I see a minus sign. Man, I like that right side. I mean, look at that. That's just beautiful. Equals 3. So simple. Left side's more complicated, so let's simplify it. Let's merge them together. And I am going to merge, because it's a fraction, by dividing. So I'm going to have one single log, because that looks so nice when it's one logarithm. And I'm going to divide. I'm going to take my 5x minus 4, and I'm going to divide by 7. There is your one single logarithm. So now, at this point, I merged. I answered the first part. What am I going to do? How am I going to merge? I'm going to merge by dividing. So now the second part, how am I going to solve? Well, I have to look at what scenario am I given? Am I given structure 1, where I have log value equals a number? Or am I given structure 2, where log equals a log? In this case, I only have a log on one side. So that means I am going to convert to exponential form. And remember, when you convert to exponential form, we ask the question, what power of 6 is my base, gives me 5x minus 4 over 7, and that power is 3. So I convert it by saying, what power of 6 gives me 5x minus 4 over 7, and that power is 3. So 6 cubed equals 5x minus 4 over 7, and I could solve that if I need to. That's part 3, though. This question is asked, what are you doing? I am merging by division, and I'm converting to exponential form. And these continue. Again, we are not solving, we're just stating the techniques. We're trying to build our ability to read and understand the problems first on it. So if we look at number 6, log base 3 of 48 minus log base 3 of 6 equals log base 3 of 6. I'm actually doing the same thing as before. Am I multiplying, am I dividing, or am I creating an exponent? That's the first thing. And then, what structure do I have? Am I going to merge and cross out, or am I going to merge and create exponents? Am I going to do exponential forms? Let's try it out. So right off the bat, I look at this and I read it. Man, that right side is nice. Log base 3 of 6. I mean, look at that. It's all by itself. It's so simple. It's so easy. But that left side is tricky looking. There's too many logs. I only want one log base 3, because then it's easy to do. So I look at it and I go, well, what can I do? How can I merge them together? Well, I am subtracting on it. And since I'm subtracting them, what I want to do is I want to use my quotient rule. I want to merge by division. So I am going to take my 48, and I'm going to take my x, and I'm going to merge those two logs into one single log by dividing those numbers together. And there we go. There is the first part. Merge by division. The second part asks, now what am I going to do? Am I going to cross out my logs, or am I going to create exponential form? It's that idea of what structure are you dealing with? Do I have log equal a value, or do I have log equal a log? And in this case, I have log equal a log. I have logs on both sides. And when you have logs on both sides, you can cross out the logs. And I'm left with 48 over x equals 6. Done. I could solve that. We're not solving here. So the question asked, what are we doing? And they're right there for us, and I can highlight it on it. We are merging by division, and we are crossing out logs. That is my answer for it. That is how I would solve this equation. Let's look at number 7. If I read it, 2 times log base 4 of x minus 7 equals log base 4 of 15. Again, which side looks nicer? That right side looks really nice. It's got this log, it's got base 4, it has 15, nothing else, all by itself. That left side doesn't look too bad, but what sticks out is this 2. It has to read log base 4 and nothing else. No coefficients, no plus signs, no minus signs. So I have to take that 2 and I'm going to I have that x minus 7 there. It's just now it's squared. That 2 slid up to the top. And now how would I solve? Because I got the first part down. I know I'm going to merge by creating an exponent. Now in this case, what do I do? When I have my 2 logs, am I going to cross them out or am I going to convert to exponential form? In this case, since there's a log on both sides, I can cross out the logs. And I would be left with x minus 7 squared equals 15. Not solving it, we're going to leave it alone. We'll solve in part 3. Here are my answers. How would I solve this problem? I'm going to merge by applying my power rule. I then see I have logs on both sides, so I'm going to cross out logs. And then I would have the ability to solve. Number 8. Let's read it. Log base 5 of x plus log base 5 of x minus 3 equals 4. Again, I mean, look at that right here. Equals 4. That side is so simple. It's one simple number. 4. It would be awesome if we could take that left side. It has too many logs. You only want 1. And I want to figure out how to merge them. Well, if I look at it, I am adding. So I'm adding, I'm going to merge by multiplication using my product. So I'm going to take my x, I'm going to take my x minus 3, and I'm going to multiply them together. Merge by multiplication, there's part 1. How are you going to merge those together? I'm going to multiply my x minus 3. Part 2 says, okay, well now, I have that. What should you do for solving? What structure do you have? Do you have log equal value, or do you have log equal a log? Do I have logs on one side, or do I have logs on both sides? Now, if I look at number 8, I only have a log on one side. So I have to convert to exponential form. And to convert to exponential form, you need to remember your question, left to right. Instead of saying the word log, I'm going to say, what power of 5? So what power of 5 gives me x times x minus 3? And we're told that power, by the way, is 4. And it's this idea of you have log, you have a base, number equals power. And these attach together. The 5 is your base, the 4 is your power, and it equals the x minus 3. We're not solving it, we're going to leave it alone on it, but that is the technique. So this video, part 2 of lesson 8.3, the main idea behind it is your properties of logarithms, product rule, quotient rule, power rule, and also getting familiar with the structure. Now, the equality part is to help us as we go further into part 3. In part 3, we're going to use these, but we're going to actually finish these problems. We're going to solve them. Right now, we're trying to learn how to read and how to analyze what format do I use, what structure do I use, what process do I use on it. So part 2 deals with properties of exponents, properties of logarithms, and it deals with equality. Do you have log equals value, or do you have log equal a log?